Okay. So homework assignment was to uh, teach a room how to kind of display itself out to the screen to some level, so you can kind of prove that a person left one room and entered another room, and then allow players to go from one room to another. Well, create the ability to take an exit, right? Although we're doing this at the high level. So out here in our main activity, we've we've created our player, we've created our two rooms, these two rooms here. We've created um, the exit that links these two rooms and let it know about the two rooms that it links. We went ahead and we added our player to the very first room. Then we want to, well, then we add our exits to the individual room. And then we should be able to, so here, this is S120 adding an exit. Do we add that exit to, yeah, here. So we add the exit S120, add the exit to CS hallway. So there's us adding our two exits. Then we're having the player take the exit to the north. So this should, or we're presuming we only have one player in here, so this should have the player take that exit associated with our hash table for north, and that should ultimately put them into let's see, north would be there, that would work. West does not work. Oh, so these were our tests. This should have given us a true, a false, and a true. And we take an exit. We're telling the room to take an exit. Here's take exit. So we're printing out whether or not that exit was found or not. We're always returning true, but this is going to display that lookup in our dictionary. Now remind me, what does the synchronized keyword do?
Allows for multiple users to, actually this allows multiple users to use the same function, calls the same function at the same time.
Okay, yeah. So same function is could be well, it disallows them from calling it at the identical time. So this builds in the protection of allowing a function to only be called once at an individual time, and it builds up the whatever the magic is to keep other people from calling it, but allowing them to call it at the next possible instant. So we don't have to do anything special on the other side. If we have three different users all trying to call this function, one of them is going to get there first and the function will lock down. The other two don't have to try to recall it. They're just put into some queue and they'll get that resource when they are able to, and it'll just work for them. Okay, so that's what synchronized does. It's a nice, easy way of building in what's called inter-process communication. So the stuff we're talking about in 450 right now, at the detail level, this is the high-level implementation of just make it work. Okay. So when we take the exit, we're just going to print out the result of getting that particular exit from our local. Historically, we would call this a dictionary, but in here, it's we are calling it a dictionary. I thought we made this thing a hash table. Oh, we did. It's a generic dictionary that we made. We gave it a value of a hash table because hash tables are dictionaries. I'm not sure why we didn't just call this guy a hash table, but we can. It's not going to hurt anything. But a dictionary was the abstract class, right? So you couldn't create an instance of a dictionary, but we could create a variable that could hold a dictionary and fill it with something that is a dictionary, like a hash table. All right, so this won't change the functionality of this at all. We just told it what it actually was. All right, so when we take the exit, we're going to try to look up that direction in our hash table. If it's found, it'll print it out. If it's not, it'll give us a null value. Couldn't find it. So let's run this real quick. Make sure it still does what we expect it to. And then we'll actually have the players take that exit when we tell it to take the exit and show the room it ended up in. So here's the exit. When we did find one to the north, here's a null when we were trying to find one to the west. Let's go back here to main activity. So north, we found that door. That's this guy. West, we don't have a door over here. That's this guy. And then from the perspective of the hallway, we have an exit to the south, and here's that thing. Now notice that these are the same exits, right? Those two guys are they're two variables pointing to the same place in memory. Okay, because we've decided to have a single exit that links two rooms. Okay, so now in the situation where a exit is able to be taken, so we want to do something like this in our room. When we say take exit, we're going to go ahead and maybe say exit temp is equal to, so now we're doing the homework. So this is the value we're trying to retrieve. Then we'll ask the question, if temp is not equal to null, then we need to actually take the exit. And then ultimately return true that the exit was taken. Otherwise, we can either put it in an else or we can just put it out here. If you like to see it in an else instead, that's fine. It's not going to hurt anything. We'll return false. False is what we're returning if you asked us to take an exit that doesn't exist. In which case we're going to say, I did not successfully take this exit. Okay? Otherwise, we need to actually take the exit. Okay, so before we do that, let's teach a room how to display itself. So let's go back to, oh, we're still already in room. So we're going to add, do we already have the function for display? Okay, so we'll add that then. This would be void display.
You said you wanted to take exit class in the exit class.
Take exit in the, oh, and we will. Because this is the guy that will actually have to take that exit. So in this code here, in here, this is where we'll actually call upon that exit right here to take the exit. Yeah, we just haven't written that yet because we're going to write display here quickly for room first. All right, so for a room, maybe we show its name, then we show its description, and then spin through and show the players that are in there. So we ask each player to display themselves. So we'll go ahead and we will. Well, we might as well teach them how to display themselves. Because we might change what displaying for a player means later, right? A player might display more stuff, might show their equipment, might show their stats, all sorts of stuff. So we'll ask a player to display themselves, whatever that means. Yeah, just, if we're just thinking about what's maybe the best way of doing this. We'll make a public void display in a player class, and all we'll do here is say system.out.println this.name. For right now, we'll just show his name. So which is effectively what you said. All right, so when we tell a player to display themselves, we'll display their name. When we tell a NPC to display themselves, even though we don't have any of them right now. So if you didn't do NPCs, that's fine. We'll also tell it to display its name. We could make an argument to create and maybe we'll do this here in a few minutes. We could make an argument to create a abstract class, maybe called entity or being or something like that, that both a player and an NPC extend, and maybe that guy would have the name, the current room, the display. It would have actually most of the things that go in here. But then where they would be differentiated is a player would have things that are potentially interactable from a human being playing the game, where an NPC is going to be much more autonomous, or doesn't do much on its own or something like that. So there certainly is going to be differentiation between a human player and an NPC, but they also have a commonality between them that maybe we're going to go ahead and pull up into a abstract class. So maybe we'll do that in a few minutes. Not part of the homework, but maybe good object-oriented design, that type of thing. Okay, so player and NPC both know how to display themselves now. A room, when it's displaying itself, we're going to go ahead and we're going to print out. So we'll say system.out.println. And we say room name, and we concatenate onto that this dot name, and then we'll say system.out.println description, and I'll go ahead and throw a carriage return in there so it kicks it down a line. So we'll say description, because description might be more of a paragraphy size thing, even though in ours it's not. And then we'll add to it this dot description. Okay, and then we're going to go ahead and we're going to show all the players that are in there. So we'll say for each different language, for player P in this dot players, we'll say P dot display. So we'll ask each player to display themselves. So this is our for each loop. We don't need to know the index where we are in that players. We just want to go through the entire list of players and print out have each player display themselves. All right, so everybody understand that for loop? Nice little for each loop. We'll do the same thing for NPC n in this dot NPCs and dot display. So we'll have all the NPCs display themselves. And then we probably also want to have the exits display themselves. Now, this becomes a little bit different because our exits, for us, we have a hash table between that has the keys associated with the exits, as well as the values associated with that. I really just want to because most games will say obvious exits. And for obvious exits, it'll say, for this room, it should just have north. For that room, it'll just have south. We don't care about the physical exit itself. We just care about the direction. So in here, we might say something like system.out.println obvious exits. Most of these old MUDs, they'll say obvious exits because sometimes you have hidden exits. You have a player that has a special detect invisibility spell or something like that. That probably in our game only Charlie would have that. You're going to play a wizard, right? You wouldn't play a wizard? What kind of class would you play, Charlie? You like a fighter or something? Yeah, like carry a sword or... Yeah, it kind of makes some sense, actually. I don't know. I always like playing magic users. I mean, you're in like this fantasy. I mean, I could run outside with a sword. I'm not going to be very good with it, but I can do it. But it's not like I can go outside in the parking lot and start casting spells.
Far away.
Well, even close up, there's going to be zero spell casting.
You don't have any shield, that's why. Your defense is always low, so you can
But I'm not going to be able to use a shield effectively in real life anyways. I'm going to get winded after like 3 swings or something. Plus, it's heavy. I don't even like carrying my laptop bag into the school. let's just be practical here. I just need a little wand for my for my spells. I was like a pencil, right? All right, so obvious exits. So now we need to go through. We're going to go through all the keys in our exits hash table. So we're going to say for string key name in this dot exits dot keys. What doesn't like that? Dot. Well, that should let me enumerate through there. Well, I mean, I already see how we can use this. It's just, I would think I could walk through this with a for each loop. Oh, I can use a key set? Ah, there we go. I didn't necessarily expect you to do this on your homework. So effectively what we have with a hash table is we have a collection of keys that are associated with values, right? So let me show you the two different things we could have done here. So when I say give me the key set here, so I'm saying from the hash table exits, because we have two sets of almost like two lists in there, right? If I get the keys, it gives me something called an enumeration of strings. Now, this guy kind of sort of works like string tokenizer. So if I say that, I would do something like enumeration string, maybe call that guy keys. So this is going to be equal to this dot exits dot keys. And then I'll say while keys dot has more elements, I'll do a system dot out dot println keys dot next element. So it'll burn past that guy just like string tokenizer does. All right, so as long as I have more elements, go ahead and grab the next element and print it out. Similarly, if I say, if I want a for each loop, and I say exits in this thing called a key set, which is going to give me think of a set as kind of like a linked list. You know, they work slightly differently. Sets are guaranteed to have unique values in them. You know, but that's a hash table. We can't have two exits associated with north, right? So by definition, a hash table would produce a set. You know, if I had two norths in a set, it would give me one north. Make sense what a set is? You probably, if you maybe have had this in a math class at some point, where a set is a collection of unique values. Okay, so I'll go ahead and get the key set, which from maybe our perspective is just a linked list of the exit names. Okay, and now I'm able to use the for each loop. I'm actually surprised I couldn't use a for each loop to go through this enumeration, but whatever. So I have two different options here. So now I can go ahead and say system.out.println key name like this. All right, so let's go ahead and let's test this and see that these do produce the same identical output. So we'll show our exits twice. Okay, and here let's just so we can keep them separated. I'll throw another little obvious exits there in the middle. Okay, so that's what happens when a room displays itself. I'm going to go back to main activity here, and we're going to get rid of our take exits for a minute. And we'll go ahead and say s120.display, and we'll say CS hallway.display. So we'll just tell our two rooms to go ahead and display themselves. Now, S120 should already have a player in there named Mike, but CS hallway does not, and neither of them have NPCs. So these rooms should look a little different anyways. To make sure my tea was vented because this thing just holds boiling stuff. It's ridiculous. Hours after you put stuff in here, it's still just boiling hot. Okay, this thing. All right, here we go. So here's S120 description, S120 classroom. Oh, we probably should have said players, but whatever. So there's Mike. Obvious exits to the north, obvious exits to the north. So we see that those two for loops do the identical things. We have two different ways of extracting the names of our keys from the names of our exits. from that guy. And here's CS hallway. Description is the CS hallway. There's no players in there, and obvious exits works in there. There's also no NPCs. I'm going to go ahead and do a little label for NPCs and players just for the sake of clarity, I guess. So I'm going to go back to room. And before we list the players, we'll go ahead and say system.out.println also here. I spelled that wrong. Okay, and then I'll also do NPCs after that. Something like that. Divide it up a little bit more. All right, so here's also here players and mic, NPCs, nothing, obvious exits, blah, blah, blah. Also here players, there's no players, there's no NPCs, and there's one exit. All right, so now for our exits, which of these two approaches do we like better? I'll leave the other one in there as a commented out block, but which do you want to go with?
We're already using the for each.
Okay, stick with the for each. All right, so I'll go ahead and I'll just comment out this dude. All right, so any questions about how these work? Now, one thing I kind of want to emphasize here is I probably have maybe used this at some point in my life, but I don't remember it. But we've taken our knowledge of programming, specifically our knowledge of programming in Java, so we kind of know Java's pattern of things, and we were able to apply it to this thing that we don't have experience using. Does that make sense? So there's kind of your evidence that programming isn't about memorization. It's about understanding the fundamental tools, and that opens up the language to you. Now, I kind of did it from the like, oh, well, that looks like it's something I probably want to use when I said dot, keys or dot key set. But I could have just as easily jumped into the documentation and flipped through there and looked for the thing that had a description that kind of sounded like what I wanted. But keys giving me this thing called an enumeration of strings, and key set giving me a set of keys, a set of strings. Both of those kind of look like they're giving me a set of strings, which is what my keys should be. So, educated guess, call it that. But, hopefully you're gathering from this that even in your careers, nobody's going to ask you to memorize a programming language. I think I've mentioned before, I've been programming in Java since the language came out. And I know very little of all the little details of the language, but I know the upper level fundamentals that you can then apply to all sorts of different things. All right, so we all learned something today, right there. And here, two different things. Okay. So now a room knows how to display itself. So now we're going to take the exit. So when we take an exit, the player is going to come in. The player should end up in the room that they're not currently in, right? So depending if this player's current room is room 1, we should remove them from room 1 and put them into room 2. If the player's current room is room 2, we should remove them from room 2 and put them into room 1. Make sense? Okay. Now I think in rooms we already did create the functions for, here's our private perform action that either adds a player or removes a player. But then we have our public functions that call upon those guys in the correct way, so we don't have to remember the exact little string to use. Right? Do you see how this little pattern works? So we have this internal function that we've decided upon our little codes for what action are we actually going to take. We only needed to remember those codes long enough to write them in here for add player and remove player. Now externally we can just call add player or call remove player and it will do the magic. Okay? So inside of exit, we're going to say if p dot get current room is equal to this dot r1. Okay, so this is a room, this is a room. Can we use the double equal sign here? Okay, so what kind of, this is a room object, right? This is a room object. When we use the double equal sign, what are we comparing? The memory addresses. Are these guys the identical room? Okay, not a room with the same name, not a room with the same description. Are they the same room? Okay?
So can we put dot equals or no?
Dot equals would not work. Let me actually check something here. Dot equals will work because it will compare two objects to each other from a memory address perspective. So it's sheer luck that objects have built into them a generic function called equals that will compare two objects to each other at their memory address. So it will work here, but I would still write it this way because this is a acceptable use of the equivalence operator. This is a primitive type, this is a primitive type because the value stored in a room is a memory address. It's a pointer, which is a primitive type. And this is the primitive equivalence operator.
What did the address be changed because you passed an input? Because the exit is the one construction, the R1 variable.
Yeah, but we're not creating new rooms here. We're passing in a memory address here, and we're just remembering that memory address.
It's passed.
Yeah, it's passed by reference. Now, it would be different if in here we said this dot R1 is equal to new room with whose name is R1.getName and whose description is R1.getDescription. Now we're building a brand new room that just looks a heck of a lot like this one. Does that make sense? Yeah. So, in this case, we just have another pointer that points to the same memory address as this guy. So its pointer count would go to 2. All right, so if we're currently in room 1, we want to remove them from room 1. So we'll say this dot R1 dot remove player P. So that'll take them out of room 1. And then we'll say this dot R2 dot add player P. Take them out of the first room, put them into the second room. Make sense? Otherwise, they'll be in the same room. And I'll show that here in a second. We'll look at the 2 examples. So the else, we must be in the other room. So we'll say this dot R2 dot remove player P. This dot R1 dot add player P. Okay, so when a player takes an exit, we determine what room is the player currently in, and they get removed from that room and get added to the other room associated with this exit. Any questions with that? Good sense? Okay. Now, in our mind, we don't need this guy to return a Boolean or anything like that because we've decided we're only going to take an exit if the exit was found. Right? So we wouldn't be calling this function unless that exit was actually found. In fact, we couldn't. Because the only way we can call this function is if we had a physical exit. So the only mistake we can really make here, well, here I'll ask you, what's the only problem we can run into here? What possible bug do we have here? And there is a fix for it.
You call the take exit and the function itself, the class.
Well, that's not a problem. I mean, because we need to have an instance of an exit to call this guy. So if I have a physical exit sitting here, I have an instance of exit, I can call this function, no problem. So if we assume that this function has been called, what issue might I run into? What kind of error could I get inside of this logic? We're making a big assumption that has to do with this part right here. Go ahead. We're assuming it. we're assuming this player is in one of those two rooms, but we're only actually asking the question, if he's in room 1, then remove him to room 1 and put him into room 2. Otherwise, remove him from room 2. We're presuming he's in room 2. Now, the hope is we would only call this under the situation where he is in room 2. But really, we don't want this to work. Well, it'll crash because we're going to look for remove player. Actually, it probably would not crash because how does our remove player work? Yeah, it would not crash because we would only actually remove the player if they were in there. But we would have an issue then because inside of exit, no matter what we do, we are adding P to room 1. But if we do not successfully remove him from room 2, now he exists in 2 rooms. He exists in whatever room he's currently in, which was not room 1. Which was not room 2. And he exists in room 1 because we added him to that. Make sense? So, possible bug. You have a suggested fix? Okay. What would the if statement say? Now, as humans, we know that we're probably going to call this function only when we know the player's in the right room. So we can almost say that we have protection from that perspective, that we know what we're doing. All right, but it wouldn't hurt to have, maybe we say else if p.getCurrentRoom is equal to this.r2. We're only going to do something if the player's in room 1 or the player's in room 2. Otherwise, we'll just ignore this. Maybe we want to do some feedback and put a Boolean out of here, whether the exit was successfully taken. Well, that one returns it, but this guy has to, yeah. The other one returns true or false depending on whether it found the exit to begin with. Then it presumes we were able to take the exit. We could have this guy return a Boolean whether the exit was successfully taken, and then if somebody wants to use that Boolean, they could. Otherwise, they could just ignore it. You don't have to use the return value from a function. So we could say this guy is going to return a Boolean. We'll return true in the 2 cases where we actually took the exit. And if for some reason we were still kicking here, which means the player wasn't in either of those rooms, which we hope does not happen, right? We're planning on using this tool the correct way. But if it did happen, we would return false, letting whoever called this function, assuming they were interested, know that this didn't work. Player was not removed, player was not added. It was as if you didn't call this function. Make sense? Okay, so now we're doing kind of a lot of error checking that we might not need if we're the only ones using the code, only ones using a program. But if you think about a larger software development application where you have a team of 5 or 10 or 100 people working on this, those other people are in your head. They don't know how you intended for this function to necessarily be called. Maybe, they could make a pretty good guess. There's some minimum level of competence that you expect them to be able to work with. But now we kind of have a catch-all. You take the exit, it'll tell you whether it happened or not, and we're only going to do anything if the player was in one of the 2 rooms. Sound good? Okay. So that's how we're going to take that exit. So now from a room perspective, when we take an exit in a direction, if that exit was found, we'll go ahead and say we're going to return temp.takeExit, and we need to give the player that is taking this exit. Now, for right now, since we only have one player in our game, we will presume it's the player at bucket 0. Right? So we'll say this dot players dot get first, or get bucket 0. get first is a synonym for get at position 0. And we'll return whatever that guy returns. Because this guy is going to give us either a true or false, whether that exit was successfully taken or not. Otherwise, we'll just return false because I didn't even find an exit associated with whatever direction you gave me. All right, so that is take exit for room, which then in turn calls take exit for exit, which only does something if the player that we're trying to have take the exit was in one of their rooms. All right, so now we should be able to go back out here. We'll go ahead and display our 2 rooms. So S120 should show that the player is in S120 and not in CS hallway. Then we'll go ahead and we're going to say S120.take exit to the north. So from this room, taking the exit to the north should work. And then we'll go ahead and display our 2 rooms again after that, which should show that the player is no longer in 120 and is now in the CS hallway. Make sense? Okay. So let's go ahead and try this guy.
So the rooms control in this game, the rooms control which exit they take. The player.
Well, for right now, yeah, the rooms probably will control because the player will be interacting with their room. So like if I'm sitting in here, I would kind of like, room, I'd like to take the exit to the north. So the room would then go, because the room has the collection of exits, it would go through and say, here's the exit to the north. You want to take this guy? So it takes a little player. It's like, take the exit to the north, and he goes. So the room kind of is the object that holds all the pieces of information about where we are. All right, so initially we see that in S120 we have player Mike. In CS hallway we have no players. Then in S120 we have no players. And in CS hallway we have players Mike. Make sense? So player ended up in the right place. It's got to be a recording. Nobody's doing anything that exciting down there. Right? All right, so this is exciting stuff. This is applause worthy, right? What's this? You'll start clapping, but only at the errors. Start cheering on the errors. All right, so now if we want to go ahead, we can test this again. Actually, let's test a failed. So let's try to take the exit to the west. We try to take the exit to the west. There is no exit here to the west. So that's going to fail. We'll never actually take the exit. So the state of the room should remain the same. Mike should still be in S120 when this is done. So there's Mike in S120 to begin with. And there's Mike still in S120 after trying to take the exit to the west. All right, so if we take the exit to the north, then we take the exit to the south, we'll go back. So after we take the exit to the north, we've already seen that we find Mike in CS hallway. So just to reduce our output here, let's just go ahead and remove that. So we'll take the exit to the north, then we'll immediately take the exit back to the south, should end up back in the original room. So these guys should look the same afterwards, even though the player technically stepped through the door, then stepped back through the door. Make sense?
I'll take the south from the
Oh, thank you. My output still would have been right, but it would have been right for the wrong reason. Actually, it wouldn't have been right. Yeah, I would have still been stuck in CS hallway because I would have tried to take a bad exit back. Actually, I wouldn't even have taken a bad exit back. I would have done the impossible. I would have attempted to do the impossible and would have failed. I would have been in that room and tried to take the exit to the south in this room.
So if you would have done it that way, we wouldn't have changed our room. Would you have changed that then? Because it would have just assumed that you're in one of the rooms.
No, because the logic wouldn't allow for that. So the very first thing I do is I take the exit to the north. So I've removed myself from 120 and I've added up and ended up in CS hallway. So now I'm in CS hallway, and somehow, because we don't have all of our stuff linked yet, somehow I'm able to try to take the exit in this room to the south. So when I'm standing out there, I try to take the exit in this room to the south. There is no exit to the south. So it just fails, right? I don't take any exit. And I'm still stuck in the CS hallway, as I should be. But realistically, we probably shouldn't be able to try to take exits from a room we're not in. Right now, we could pull that off because we're kind of like, doing we're pulling the strings on the puppet. Right? The player isn't giving their own input. We're saying, player, you're going to take that exit. And then we're saying, player, you're going to take that exit. Well, that then technically allows us to tell a player that's in that room to take an exit in this room, where that wouldn't be able to happen in our actual game where the player's making decisions. The only exit they would be able to take are the exits that are in the room they're currently in. Okay, so this should have them go out there and come back here, so we should have the exact same. Final state of our rooms, even though in the middle the state did change. So there's Mike in S120. And here's still Mike in S120. Make sense? All right, so now let's go ahead and do what we mentioned before. Let's draw a little picture of what we're trying to accomplish here. So we have our NPCs and players. What's a generic term for living things in our world? Entities? You like entities? Characters aren't bad. Like, you just like characters? Okay, we'll deal with characters, just because we don't want to have his answer. I picked you. All right. All right. I'm going to applause. All right, so we have a character class, but we're going to make this guy abstract. Because we do not intend to create instances of characters. We intend to create instances of things that are characters, but not instances of characters themselves. All right, so we're going to have a player inherit from character, and we're going to have an NPC inherit from character. But now we need to look at what are the common functions between all characters. So all characters are going to have a name. Let's go back to our code here. All characters have a display function. And all characters have a current room. So that's something that's common among all characters. Correct? All right. So we're going to have a name. We're going to have a room, current room, and we're going to have a public display function. And then probably our getters. So getters and we need to have a setter for current room as well. All right, so what we'll do here is we're going to go into my app here. Create a new Java class, and we'll go ahead and call this guy character. And if we want to, we can go ahead and actually select that modifier for this guy and say it's abstract. If we don't want to have to type it ourselves, we can select it there. It'll create the class as an abstract class. And I'm going to say, remember, don't ask again. Yes, I want to add it to my Git repository. So there's my public abstract class character. And then I'm going to go into NPC or player, doesn't matter. I'm going to steal their private variables, except we're going to make these guys protected so that children have access to them, right? If I make them private, where is a private variable accessible? Only in the class named character. So if I want name and current room to be accessible from player and NPC, I need to make these guys protected, which then extends privileges to the children of this class. Make sense? All right. Then I'll have my public constructor character. This guy will take in a string name and a room. Actually, I don't think it takes in current room. It just takes in a name. And we say this dot name is equal to name. This dot current room is equal to null. Okay, so that's the constructor for that guy. So now what we'll go ahead and do is inside of player, we'll say this guy extends character. And then for player, the very first thing we'll do is we'll go ahead and call super name. We will call upon our parents constructor to go ahead and set up this player. Make sense? And right now, players and NPCs, their setup is identical. In the future, we might change their setup a little bit, right? They might still set their name and current room the same, but then we might start differentiating between NPCs and players. We'll do the same thing to NPC. We'll say that this guy extends character. And we'll go ahead and say super, pass it the name, calling upon our parents constructor, which only takes in a string, and have him set it up. All right, now we decided that characters should have a function called display. So I'm going to actually take it out of here, and we'll go ahead and put it into character. And we'll also go ahead and remove it from player, because it's going to get this through the inheritance model, right? Similarly, for get name, get current room, and set current room, all those things are things we can move into our abstract class, because those are things that are going to be shared among all the children of this class. Make sense? All right, so we'll do the same thing with NPC. We'll get rid of these guys. All right, so now NPCs and players look pretty boring, don't they? There's an NPC. There's a player. Players also don't have a string name. So there's a player. There's an NPC. Not a whole lot of stuff going on with those guys, but their functionality will be identical because now they're supported by this abstract class. Go ahead and run this again. And we see we were still able to get the player's name, so on and so forth. Well, this actually asked the player to display themselves. And then the player basically said, character, display me. Right? Now in the future, we might further differentiate how players are displayed compared to NPCs, and then we can have a display method inside of player. So for example, let's go ahead and show that. If I'm in player, I can go ahead and I can have a public void display. And I can maybe print out well, let's do a system.out.println I am a player. All right, just saying that for right now. So now this guy is a more local definition of this function than the one that lives inside of character. So just like variables are resolved, functions are resolved the same way. If we ask an instance of player to call his display method, the first place a player is going to look is inside his own scope and say, ah, I have a display method right here. The search is over. So it'll call I am a player. So if I run this again, we'll see that this is the function that actually gets called. So we're no longer going to see Mike, we're going to see I am a player. There's my I am a player. Make sense? But if I want my parent to do most of the work, and then I can just add in the extra little bits that maybe make something about me special, I can go ahead and at the beginning, well, anybody want to tell me how I can do this? Super.display. So go ahead and ask my parent to call their version of display. Do whatever that's going to do, and then I will augment that with some extra stuff, which doesn't make sense right now, but you'll see it work. Okay, so we'll go ahead and call this. Oh, I'm already in the right place. So now we should see Mike followed by I am a player. There's Mike. So that's what super.display did. And then this is what display did for player. I am a player. It did the two things. Make sense? All right, so we haven't actually changed the functionality of our program. Well, right now we have. But if I go ahead and take that guy back out. We haven't actually changed the functionality of our program at all, but we have improved the object-oriented nature of our program by saying, we're pretty sure that players and NPCs are going to further differentiate themselves from each other in the future. But right now, they have a whole lot in common. So we might as well put those commonalities in this abstract class. Do we have to make this guy abstract? What will happen if I remove abstract here? Will the output of my program change? Sure. Still extends it. Super has nothing to do with abstract. Super has something to do with the inheritance model. We still extend a class called character. Make sense? Yeah, so super is about inheritance, not about abstract. All right, so output of this program will still be identical. We don't have to make that class abstract. But by making it not abstract, as he pointed out, now we are technically allowed to create instances of that class. Even if we don't intend to. By putting abstract in front of it, we say we are policing ourselves. We're not going to allow somebody to create instances of it. And we actually saw an example of this last class, right? I wanted to make an instance of dictionary. And we found out that dictionaries were dictionaries defined as an abstract class or were defined as an interface? I think they were defined as, it might have been an abstract interface actually, but whatever it was abstract. Okay? I couldn't create an instance of dictionary. I had to either extend dictionary myself and make my own class, or use one of the classes built into Java that have already extended dictionary, like hash table. Make sense? All right. So it's in our best interest to make this guy abstract, because now we are self-policing our code. We do not intend to create instances of characters. But we could if we wanted to. Right now we can't, but if we took abstract off, we could if we wanted to. Good.
Can you explain protected again? Like the keyword protected.
Yeah, so we have 3 different levels of protection, right? We have public, private, protected. Public means we can access it anywhere. Really, it's anywhere in the package. Just allow that to be correct for right now. Private means we can only access it within the class in which it was defined. So if I made these guys private, they would only be accessible inside the class called character.
It doesn't like extend it.
No, only in that class. So that's where private ends. Private says only here. So we would not have access to those guys from player or NPC. Protected loosens the restriction just a little bit and extends access to the children of this class. All right. So the difference between private and protected from our perspective is that protected now allows things that extend character to also have access to these variables. But not just anybody. Only direct descendants. Only descendants, not direct descendants. So you could have a class that extends another class, which then extends that class. And it would still have access to it because it's in the lineage. All right, that makes sense?
Yeah. I have one more question.
Sure.
How do you use the keyword add override, or is that just?
No, see, that's actually not a keyword. The add override is a so there's this thing called JavaDoc. So JavaDoc is a self-documenting protocol for Java. So if you put in the right little keywords before functions, and so if we go back here, let me just open up. I'll just go into string here. Oh, there it is. So it's in java.base, then we have java.lang. Lives inside of java.base. Interesting. So let's go to string. All right. So all these things in, let's get down here. Let's go to the methods. So method, here's its return type, here's the name of it, and here's its description. These can all be generated using a program called JavaDoc. If they put the correct little, I think it's called @description or something like that, before your function call, JavaDoc, as it's going through your code, will look at a class. So in this case, it looked at a class called string. It found a bunch of functions. Before that function, it had an @description, which gave a paragraph or whatever about it. It will go ahead and generate something like this exact format. So it'll generate a bunch of web pages. That is the documentation for your code. Does that make sense? So all those things are mechanisms for quickly documenting your code as long as you've taken the extra time to insert those directives into your code. Make sense? So the override thing specifically, which you asked about, if I scroll down here, I'm sure there's some in this one. Well, this guy doesn't have overrides. Does not have overrides. Let's go to java.util. Let's go to hash table. All right, so you see the inheritance model here for hash table, right? So hash table inherits from dictionary, which inherits from object. So now let's see if we have a list of overrides here. We don't. So just like we don't have overrides in our current thing, anything that's in the generic class stayed there and only new methods were defined underneath it. But overrides would show up in the JavaDoc as this is a function that has been overridden from a parent thing.
So it's just for documenting.
Correct. It's a documentation syntax. It's the JavaDoc syntax. So that's the scoop with that. Certainly a good idea for larger projects, or if you're writing your own. So like right now we're creating an application where our rooms and characters and players and NPCs, all those things are very specific to our implementation, right? But let's say we were writing let's say we thought we had a faster version of a linked list. Just pulling that out of the sky. We could write the linked list as its own class, and that would be something that we really intend to share with other people so they can use it inside of their code. That makes sense? Fairly soon in here, we're going to be incorporating Firebase. We're going to be incorporating a database into our code. So we're going to be using the API from Firebase, and that's something that they wrote that might be beneficial to all sorts of different people that want to store stuff in the cloud. All right? So they probably use JavaDoc to generate the documentation for their Java API, for their Java API, so that they didn't have to go through and document it, create this whole structure, because people who are used to using Java are used to using the structure that looks like this. So they can get the documentation for this thing that wasn't made by Sun Microsystems or Oracle in today's case, but instead made by Bill. Bill can make his documentation look like their documentation, so it's already in a familiar format. Make sense? So less about a programming thing and more about like a self-documenting type thing. I'm not sure how often it's used nowadays, because it would be very specific like that. Like we probably wouldn't use JavaDoc in this type of thing, since all of our objects are very specific. It wouldn't be all that beneficial for us to hand our room object to somebody else and say, go ahead and use this if you want, because we really have coupling involved in our program, right? So some of the things you've been talking about in 370 deal with coupling and how, avoid it if you can. Well, certainly things like linked lists would be not coupled, because those are kind of standalone utilities that anybody can use. Well, we're much more specific here, where we have quite a bit of coupling between our objects, which is okay, but we want to understand that's the world we're operating in. But that isn't to say that our code shouldn't still be documented. So you can either internally document it using comments and things like that, or you could use JavaDoc so that you have a convenient thing to just pass to you hire 2 new developers for our project, and you want to give them a convenient way of seeing how the stuff works. JavaDoc would make sense for that as well. And I actually bet that Android Studio has a JavaDoc builder.
I know this like the keyword, not really, but I do it from the IDE.
So I'm going to right click here. I'm going to click on generate. Yeah, but that's not, I'm looking for specific JavaDoc. Just look it up real quick. Android Studio, JavaDoc, generate. How to generate JavaDoc comments in Android Studio. You could type /**. No, that's not right. Yeah, see, this is like JavaDoc format. Yeah, see, they're saying it will show this type of thing. What do you think? That would really surprise me if it would surprise me if it's not built in, but I haven't used JavaDoc in literally years, probably a decade. Because at this point, I've legitimately just become too lazy to comment. Is what it comes down to. So it was, just like I appreciated her telling me it was her 21st birthday and him saying he went to the Brewers game. I'm too good for commenting at this point. Is what it is. But that's always the problem. I go back and stare at the code and say, what was I doing last time? So, but Java Doc's a thing. Maybe there's a plugin, maybe it's built into it. I'm not sure. It is handy, especially if other people are going to look at your code. And there might even be something that's newer than Java Doc that accomplishes the same thing. So Java Doc's kind of the last self-documenting thing I know of. But it's possible there's even something, maybe that's why it's not built in. There might be a generate documentation or something like that in this that literally goes through and kind of scrapes your code. Just out of curiosity. Export to HTML? What does that do? Let's put this on our desktop. Let's see what that guy does. It might just show the contents of the file in HTML so it's easy to view. I'm going to do this again so I can find it. So I should get a new file down here in a moment. Yeah, just puts the code in a format that you could easily share with somebody, I guess. That's dumb. What's up?
That's what Slack is for.
Yeah, exactly. That's what Slack is for. Okay. Well, so I guess let's leave that topic for now. Yeah, it's okay. Because I mean, Java Doc is a thing, and it's at some point you're going to run into it and that kind of stuff. Okay. So now let's think about what should come next. We probably want to start moving this towards having an interface in our Android application, right? So right now we kind of have rooms being represented. Okay, so let's do this for our next assignment. Let's kind of build out an interface of what we think a room should look like. So we're going to say that, here's a screen of our application, right? So up top here, maybe we have the name of the room. Yeah, so let's just show one room. Then we'll start thinking about navigating rooms. All right, we'll take one little steps here. So we have a name. We have our description. Yeah, we're going to actually build a screen. So for the homework, you're going to build the interface for your screen and maybe just show the S120 room. Something like that. All right, so we'll have name, we'll have description, we'll have call it characters for right now. Probably want to put this in like a text view inside of a scroll view type thing like we've done before with our linked lists and stuff like that. So we'll have characters, text views inside scroll view. So you kind of have you have 50 characters in there. You'll have players and you'll have NPCs. You can kind of scroll through those guys. Then we'll have obvious exits. All right, so obvious exits. Now we want these guys to be clickable. So initially what we can do is we can make the assumption that we have only the 4 cardinal directions, north, south, east, west. All right, so we'll have, we will dynamically generate, but just for right now, for this exercise, we're going to have 4 of these. Actually, maybe we want them to have the, actual kind of look like cardinal directions or something. North, south, east, west. And these guys would be buttons. They don't necessarily do anything yet, but that's what they'll be. They'll be buttons. And you should have only the ones of these show up that are appropriate for the room you're currently in. So for this room right here, west, east, and south would be invisible. We would not see those, right? Because only north is an exit that exists in this room. Make sense? So for Tuesday, build out this interface for S120. Or CS Hallway, doesn't matter. But do it for S120, I guess. And when your app launches, have it just show S120. It doesn't. The buttons don't have to take you anywhere. It should just be filled up with the information.
What needs to be button?
Huh?
What needs to be
The reds are buttons. So these 4 guys would be buttons that would presumably, when we click them, would take us to another room. And we'll look at that on Tuesday, okay? So right now, just get the buttons in there, hide the buttons that aren't available, and then show all your information for name, description, and the characters that are in the room.
So do we use different screen for different room?
Well, we will, but for right now, you're just going to have just main activity can have this in it. And we'll move that layout around later on. But for right now, you're just showing one room. And you're showing only S120. Make sense? This is all a visual thing.